Hello everyone. We will continue today on limits at infinity. In today's session, I'll be talking about we are having limits when there are square roots involved. So it's like a special case of limits at infinity with square roots. So the first important thing to remember is that if your x is greater than 0, then the square root of x squared is x, but if x is strictly less than 0, then square root of x squared is minus x. Remember, what it simply means is, remember, if we take if x is 2, then 2 squared is 4. And in this scenario, when x is minus 2, again, minus 2 squared is 4. So the square root of 4 or the square root of minus 2, in the case of x is minus 2, is minus x. Okay, so this is important for us to keep in mind because we're looking at limits at infinity. So that means here, kind of when x is going towards negative, very large negative numbers, that's the kind we look at limits at infinity. When this is the scenario we'll be looking at. So let me start with an example to show what I'm saying here. So the first example is the limit as x approaches infinity of 3x minus 2 divided by the square root of 2x squared plus 1. Now, because the square roots are involved, so we'll have to, you have to be very careful. Because in the numerator, we have a linear function, whereas in the denominator, we have a square root function. So keep in mind, this is not a rational function. Rational function means a function where a polynomial over polynomials, okay? So the limit as x tends to infinity of a function where you have a linear on the numerator or a square root and the square root in the denominator, or vice versa. How would we solve these problems? Okay, so the first thing we're going to do is, where is my x going? Oh, x is going towards infinity. That means x is positive. So in that sense, the square root of x squared would be looked at this. Okay, so let's solve this problem. Limit as x tends to infinity of 3x minus 2 over square root 2x squared plus 1. Remember, in the numerator, here, we are going to divide by square root of x squared, which is x, and in the denominator, we're going to keep a square root of x squared because here are square roots. On the top, there's a linear function here. So what happens when you divide by 3x minus 2 over square root of x squared, because this is a linear, so you have to write it in the form of no square root. So 3x minus 2 over x. So when you solve this one, what you're getting? 3 minus 2 over x. That's what we have here. Now let's look in the denominator part. We have square root of 2x squared plus 1 over square root x squared. So let's look at this here. So we have square root of 2x squared plus 1 over square root of x squared. Now we're going to remember, I hope you guys remember your radical root functions. If you have a square root over a square root, you can write as this whole expression under one big square root. Okay, so it's going to be 2x squared plus 1 over x squared. And that's what we have here. Okay, so now you have a limit 3 minus 2x divided by square root of 2x squared plus 1 over x squared. Now this we can further work because, do some little simple calculations. We get 2 because 2x squared divided by x squared. We're going to divide, basically separate the numerator terms. So it's 2x squared over x squared plus 1 over x squared. So 2x squared over x squared is what? A 2 plus 1 over x squared. Now, this limit is still here. Now I'm going to take the limit in the numerator, limit in the denominator. So from here, we are saying limit x tend to infinity of 3 minus 2 over x. These are all the limit laws we learned in the earlier chapters of square root of 2 plus 1 over x squared. Now, top, you simply get a 3 because 2 to the power x, what happens? It goes to 0. Okay. Now, remember the limit laws. This limit goes inside. Okay, so this simply means square root limit x tends to infinity of 2 plus the limit x tends to infinity of 1 over x squared. Okay, now what happens? The limit of 1 over x squared, we all know, is going to go to 0. So what you're going to have is a 3 over square root 2. So limit of 2 is a 2. So 3 over square root 2. So the answer for this one is 3 over square root 2. Now let's look at another example where x is not approaching infinity but negative infinity. Okay, let's do that. So here, limit as x approaches minus infinity, 3x minus 2 over square root 2x squared plus 1. Now, as x is approaching becoming negative and negative, that means the square root of x squared is minus x. So, we will divide this numerator by square root of x squared. So, this one, remember, is 3x minus 2 over square root of x squared divided by square root 2x squared plus 1 over square root x squared. Now remember, in the numerator, 3x minus 2 has no square root. So we will change the square root x squared into minus x because, oh, I forgot. This is x approaches minus infinity. Yeah, everywhere, guys, it's x approaches minus infinity. I will definitely make the changes in the notes. Okay, so what happens here? So this one is the same as we did in the previous slide. So this one would be now 3x minus 2 over negative 2. And remember, we're going to get this under one big square root function, 2x squared plus 1 over x squared. And this is an x, sorry. Okay, so what do you have? 3x minus 2 over minus x. And then this is written as minus 3 plus 2 over x. And this one simplified is 2 plus 1 over x squared. I've shown you the process in the previous slide. So now you take the limit. This goes to 0. This goes to 0. You have minus 3 over square root of 2. Okay. Let's look at a graph of this function. Notice, as your x is becoming positive, this function has a horizontal asymptote y equals 3 over square root 2. And this is the function which we just solved. And as x approaches negative infinity, the horizontal asymptote is y equals negative 3 over square root 2. Okay? So we see that functions which are not rational may, it says may, okay, may have different right and left horizontal asymptotes. So this was a very, very specific scenario where we're looking at limits and infinity of functions where square roots are involved, radical roots are involved also. Okay, now let's look at infinite limits at infinity. Now there are many functions which will not approach a finite limit as x increases or decreases without bounds. Remember, when we say the word x increases or decreases without bounds, that means we are saying x approaches plus infinity or x approaches minus infinity. That is the mathematical notation for this language. Now, it says, for instance, no polynomial functions has a finite limit at infinity. As simple as this. Limit as x tends to infinity, say, of x squared. It is going to infinite because if you look at the graph, what happens? As the x value increases, the function increases on both the sides. You see that? So that's why no polynomial function will have a finite limit at infinity. Okay, let's define this now. If f is a function which is defined on an interval, minus infinity to infinity, the statement that the limit of the function as x approaches infinity is infinity. Mathematically, you're going to say for each positive number m, there is a corresponding number n greater than 0, such that the function value is greater than m whenever x is greater than n. On the other hand, the limit as x approaches infinity of fx is minus infinity, that for each negative number m, there is a corresponding number n strictly greater than 0, such that fx is less than m whenever x is strictly greater than m. Give me a second, guys. Let me make sure that that's the correct theory I'm applying. Just want to make sure, guys. Yeah, that's right. I was a little doubtful, but that's right. Go ahead. Okay. Now, so similar definitions is that this limit, if it's not always going to be x approaches infinity, it can be x approaches negative infinity. It will be still the same answers. Okay. A very classic example of a cubic function. So we would like to find the limit for the following function. Limit as x approaches infinity, x cubed is infinity. Notice what is happening. As x increases, the function value is also increasing. Now, when you have x is approaching minus infinity, that means as x is decreasing, the function value is also decreasing. So when it says minus infinite means x cubed also decreases without bounds. As x decreases without bounds. So you have to be careful when I say x approaches minus infinity. Literally I'm saying is x is approaching or decreasing without bounds. So when I say x is approaching infinity, that means x is increasing without bounds. You can't define an infinity, we all know. It's something lying somewhere outside, but it is there. Okay. One more example, guys. Okay, so this is a function. You can look from the graph. The function is x4 minus 3x over 2x squared minus x. So when you look at the graph, notice as x is approaching infinity, negative infinity, the function is increasing. Whereas when x is increasing without bounds, again the function is increasing. In both the scenarios, the function is increasing, remember. Okay, as x increases without bounds or x decreases without bounds, the function is increasing without bounds too. Okay, let's do the math. Limit as x approaches infinity. X to the power 4 minus 3x divided by 2x squared minus x. We'll apply the same rules. We would look, it's a rational function, first of all, a polynomial over a polynomial. We will divide by the degree of the denominator, which is 2. So we're going to divide the numerator by x squared, and we will divide the denominator again by x squared. So then we just simply look at the, this is a complex fraction if you see that. So here what you're going to do is you're going to separate the terms in the numerator. So x4 divided by x squared is x squared, minus 3x divided by x squared is 3 over x. Similarly, in the denominator, you get 2 minus 1 over x. So when you take the limits inside, so that means the limit is as x approaches infinity of 3 over x approaches 0, 1 over x approaches 0. Now, the limit of 2 as x approaches infinity is 2. But the limit of x squared as x approaches infinity is infinity. So this is infinity over 2 is infinity. So that means this is the infinite limit and infinity. And we can see it from the graph too. Well, now it's time for practice problems. So here are a bunch of problems for you guys to practice. Thank you.